So the first thing I wanted to say was I want to become a mentor. I'll talk with you, Derek, about how to do that. That's an extraordinarily important activity. I wouldn't have gotten where I am without mentorship, without the guidance and counsel and feedback from trusted folks who are senior in the industry. So um, let me talk a little bit about who I am and why we're doing this. I've been in IT, as Derek pointed out, 46 years now. Started as a COBOL programmer, went to IBM and worked on OS development for the MVS mainframe. Left there after 12 years and joined Gartner, where I ran the information security strategies group and also the application integration and middleware group. Um, Subsequent to that, I was for a while a senior director with KPMG, acting as an enterprise architect, particularly for information security and identity management. Became CTO of an identity management company called Waveset, and it was the predecessor group of what is now SailPoint. Served as an independent consultant for a number of years and joined Trend Micro about 4.5 years ago. My job there is to talk about information security and related topics to raise awareness and to help people sort out what they are and are not doing that may or may not improve their posture. So, as for the presentation, we're going to go through four main areas. First, we're going to talk about what smart factories are. A lot of time people say smart factories and stop there, like smart devices. Everybody knows what they are. Well, it turns out there are a significant number of smart factory styles, and we'll hone in on the one. This is not paid announcement, but it turns out that the IBM model is the one that we'll adhere to, although the Japan model is inspiring. Then we'll take a look at, within that framework of ideas, we'll take a look at known attacks. We actually ran a honeypot for a while, and about 8 months, and we got some interesting data out of that. Then we'll move into what we see in the future, and we'll finish up with remediation. Now, in the course of remediation, I'm going to be discussing concepts that basically come from the IT security area, but I want to emphasize now, and I will again, that the information security people have a heck of a lot to learn from the ICS people about architecture and about policy and about the structure of their approach. And so we will talk about that clash between IT and OT in the course of the material. And just one final note, if you're wondering what the design is here, Trend actually hired half a dozen data artists, and this design is actually a visualization of information from about a year's worth of ransomware attacks. I don't have the key as to which elements of the attack are there, but as you know, it starts with a phishing email or a bad link you shouldn't have clicked or a download. Then there's lateral movement. Then there's the establishment of additional resources that the ransomware villains will then deploy. And then there's the ultimate attack. And finally, the remediation, the fixing of it. So we have a series of these graphics, and I think I give credit to the particular data artist on the final slide. So let's begin. Types of smart factories. The four or five most interesting ones. Germany has a wonderfully detailed architectural model, Industry 4.0, and there is a formal specification about what that is. It drills down hard into the details of a structure. Think of it as the Purdue model on steroids. The European Union has a more high-level conceptual one, Factories of the Future. NIST has developed a series of documents relating to the Advanced Manufacturing Technology Consortia, and our Industrial Internet Reference Architecture, IRA, illustrates that approach. As I said, the Society 5.0 from Japanese Cabinet Office is a fascinating look at the future, exciting and uplifting. Here's what they are looking at. They see Society 5.0 as, and I'm going to quote this, a human-centered society that balances economic advancement with the resolution of social problems by a system that highly integrates cyberspace and physical space. Now, you may hear something of the metaverse. This isn't that. This is more about having machinery and AI support and enhance one's life experience. So, Smart Factory is just a part of this. Being able to use available information sources to help people create new value, both in the economic sense and also in terms of the enrichment of one's life. On the top right, we talk about ways to overcome constraints. This is more related to Gene Roddenberry's vision than it is to Mark Zuckerberg's. Um, on the bottom left, being able to eliminate um, dull, repetitive work, the satanic mills, being able to use not just machines to amplify human strength, speed, and precision, but also intelligent means to amplify human thought, reasoning, and connection. So that's a tremendous goal. And then finally, of course, on the bottom right is using robots, helping people get things done. Um, this utopian idea is exactly the kind of thing you'd expect from a society that always manages to take the long view. Um, as I said, the IBM Industry 4.0 is more prosaic. It's down to earth. It starts with what we have today. And it talks about a threefold architectural model with heavy emphasis on edge computing. That's the column to the left. This is where you access not the internet, but the nearby stuff. The idea behind edge is not to replace the internet, but to overcome the latency that normal internet connectivity always drags in. So we're talking about smart devices that are able to interact with data, with analytics, with rules to affect um, production, productivity, quality, and training. Now, it's not all sunshine and roses. Bruce Schneier said at a conference a few years ago that if you take a look at what's going on, we're deploying more and more sensors, we're gathering more and more data, and we're creating more and more sophisticated machines to analyze and draw conclusions and form actions. So you have actuators out there, things that are speeding up or slowing down cars, things that are opening or closing doors, things that are guiding traffic. You have sensors, actuators, and a huge body of information with analytics around it. And when you put that together, what you've done is you've created a gigantic robot. Okay. Now the question is, how much thought have we given to securing the content of that robotic infrastructure? And the answer is not a whole lot. And that is a real vulnerability. So we'll be talking about security large issues, but we'll be talking about very specific detailed security issues. Just bear that in mind. On the right-hand side, we have the plant, call that the ICS domain, and the enterprise, which would be more characterized as the IT domain, and they're communicating directly through local or hybrid cloud. And the goal here is to optimize production, to minimize side effects such as environmental impact, to make sure that we're observing the health and safety of the people doing the work and the community in which this work context is embedded. The addition of edge means that you can have subsets of the information from this enterprise made available selectively to other enterprises. Now, my mind immediately says, well, that's great because that means we'll be able to share information about attacks and so on. And that's the whole notion of the ISACs, the Information Sharing and Analysis Centers, where people can bring together data about what kind of threats are going on. But in a much larger sense, we're talking about keys to productivity. Once upon a time, an online reservation system was a unique competitive advantage. American Airlines Sabre system was a world beater. Initially, it was travel agents and American Airlines personnel who could use it to book flights. but then they broadened it and allowed people to book their own flights. Now, an airline that does not have an online reservation system is woefully behind and has a huge hill to climb. It's a barrier to entry. So what was once a competitive differentiator has slipped back into being part of the context. And that's what Edge is going to allow us to do. It's going to allow us to take those things that an enterprise or a research organization or a university discovers that could be helpful to business processes and make them public, and keeping the really good secret stuff, of course, internal, but making it public so that everybody gets a little better at doing it. You find a way to sequester carbon that itself is less impactful on your manufacturing or supply chain or distribution or consumption, then why not make that thing public after you've launched the press release and gotten a seat at Davos and all of that good stuff. So it's the IBM architectural model that we'll talk about. And what I want to point out here, particularly for the purposes of this discussion, is the vast attack surface that we're talking about. And although it's not shown here specifically, on the right-hand side, along with the enterprise, we have the employees of the enterprise who will be, to a large extent, working outside of the bounds of the traditional organization. People working from home. At first, we thought that was going to be a temporary dislocation and that people would be coming back to the office. Well, they're not. 70% of the people are working from home. They have for white collar people are working from home. They have for the last 5 months. The number was a little bit higher, but every indication is that it's not going to drop very far below that. Organizations that are insisting that their entire workforces return to the office are finding considerable pushback and, in fact, are seeing their employees leave for a more congenial work environment. That's a good thing for the overall stock of human happiness. I'm thinking of Nepal, is it, or Bhutan, that has that wonderful index of happiness as opposed to gross domestic product that they use to track their success as a society. Well, what we're looking at here, though, the flip side is that now, as I'm working from home, my entire home network is an extension of the enterprise's network. And that means a dramatic increase in the attack surface. Just as an aside, yesterday, Trend Micro started its Austin Pwn to Own event. This is a 3-day contest for talented individuals to see if they can crack into various things. It started yesterday. It's continuing through tomorrow. There are significant prizes, 5-figure awards for people who come up with the greatest hacks. And we've seen successful attacks against home routers. That's the most often attack point. But the diversity and density of smart or more than dumb, let's say, programmable devices in the home is dramatically increasing with the shift to work at home, and that is dramatically increasing the threat surface. So with that as background, let's talk about some known attacks. We ran a survey in November of last year, and we have some data from that. And we also ran an 8-month Honeypot in most of 2019, and I'll share some data from those experiences now. First, let's talk about smart factory cybersecurity incidents. With a survey of 500 individuals, have you experienced a cybersecurity incident in your smart factory? Nearly 2/3 said yes. Have you had an incident that stopped production? And of the 306 that did, 3/4 of those found production interrupted by cybersecurity. And for the ones that answered this question, how long was it out? 2/5 said it was more than 4 days. So we're seeing a decreasing population. That's why the numbers don't seem to line up. 500 folks asked the first question, 228 asked the last one. Cybersecurity is a real problem. This was a survey of IT and OT supervisors and directors in the US, Germany, and Japan. We do have splits in the report. The document is publicly available, showing how things vary by country. but I'm dealing with the summaries here so you get a context for what we're seeing as overall. We also asked, um, is the organization doing a good job with improving their cybersecurity of smart factories? And we asked 500 individuals. On the left, you see the aggregate response. On the right, however, you see the split between folks that come from the IT side and folks that come from the ICS, the OT side. In most areas, they're pretty closely aligned, although surprisingly, the OT people tend to be uh, more optimistic by a few percentage points across the board. What's interesting to me is the areas where there's a substantial divergence. That fourth question, um, the concern about system assets and their importance not being listed. That challenge is seen as a significant problem by, well, 3/5 say it is a problem. 2/5 of the IT people say we're doing a pretty good job, whereas the OT people think over half of the time things are great. And we see that theme again, where are we identifying cyber threats and vulnerabilities? The OT people seem to think, yeah, we're okay. The IT people say, no, not so much. Do we have a target level? Do we have an acceptable, if you will, baseline set of controls that we want to meet? Well, IT people say, well, we're kind of short of that, and the variance is almost 10% swing between those. That is a significant problem. You can't fix something if you don't know you got a problem. So what this message here is that the IT people and the OT people need to come together and determine where exactly these lines are. Think of this as a snapshot of a gap analysis. And here the gap analysis says that the OT people think IT is doing a better job than the IT people think. That's worrisome. So let's take a look at the Honeypot. We'll bring in some more results from this survey shortly. We launched the Honeypot in May of 2019, and it ran through the end of the year. And we did this stateside, and we did this by taking a look at real threats, creating a factory honeypot. Say, oh, well, okay, so you put out something there and you see who takes a look at it. Well, it turns out that first part, putting out something there, is a non-trivial exercise. We wanted to make this thing look real, which means we had to fool both people and machine intelligence. They would say, oh, okay, this is no good. Because if you go out to a Shodan and search for the tag honeypot in Shodan, you're going to find there's a lot of them. There's over 4,000 running. So Shodan looks at exposed ICS devices and is able to say, okay, this just doesn't seem right. We're not going to consider this a real environment. So this is legitimate. This is what detected. It knows that it's a honeypot because some of the settings are just not normal. A honeypot has, if it has all its network ports open, and if it's connected to an observable program like HoneyNet, which is used to run honeypots, it's in an all virtual environment, or it has no internal communication traffic at all, then, as Jim Foxworthy says, you're probably not a real factory. So what we did within Trend was we built a real factory. This is the configuration. Some of it's running in virtual machines, but some of it is actual physical devices. There's a router, there's a firewall, there's a switch, there are 4 PLCs, there's a file server off of that, and then running as virtual devices on the lower left, you see our HMI console, a robotic workstation. Those technologies are virtualized, but those aren't the things that you would be going after most likely today. Next time around, we're doing a real robotic workstation, and that's already started. The results will be published early part of next year. So we put this thing up and we said, okay, how'd we do? Well, Shodan said that, yep, that's a real That's a real system. That's a real device. It is a true ICS. And we decided, you can fool Shodan, but you need to fool people too. And so we actually created a backstory, uh, website, discussion of our clients. Honey Company, it's a small industrial prototyping boutique working for a specialized set of customers in the military and in high tech. We created backstories and Facebook profiles and LinkedIn entries for the individuals who are in the organization. These are AI modified um, uh, images. The gentleman on the top right, that photo is actually based on a fellow that I used to work with here at Trend. But there was enough there that a cursory or even moderate probe would say, yeah, this seems real. These people are real. And inside the environment, we had email traffic. We had messages being sent and received. We had orders being submitted and processed and shipped. We had communication with vendors. We had updates being installed on systems. So it looked real and it acted real. And we kept it up for, as I said, 8 months. And here's what we found. Over the 240 days this was live, we got 30 cyber attacks. 5 of them were people installing crypto mining tools. We had 2 ransomware attacks. We were used 4 times as a platform for other fraud, launching spam messages and such. Half a dozen of these instances impacted factory operations. Interestingly, though, nobody stole any information. We were expecting to see that. We were expecting to see people messing with the technology, the ICS control systems directly. And it happened fast. This site was up 15 minutes when it got its first scan, got its first attack. And here's what we found broken down. We had 3 attacks in July. That was the crypto mining. Those are the fellows that are hungry for anybody who's dumb enough to allow access to a device that they can start stealing cycles from. A lot of money to be made in cryptocurrency mining. That's a perennial problem. It's not unique to ICS at all. In August, a significant boost in attacks. I guess people coming back from vacation. Um, we actually had 2 instances where you'll see on the top right in the beginning of November, we got a note from a hacker who called us to say, "Hey guys, your system's not secure." It was like, "Oh my gosh, we'll have to do something about that. Thanks for the call." Um, but here are the ones that actually impacted operations. In August, towards the end of the month, we had an attack that shut down the system. We had instances of ransomware in September and October. And in December, we had people dinking with the HMI settings. We did have the ransomware attacks encrypting data. They screwed up the PLC logic file. We had full backups, and so we were able to reinstantiate the environment. So we were able and ready and looking for this kind of stuff. But we can conclude definitively that even if the attacker isn't aiming at the factory, they can mess up the factory. Now, sometimes it's self-inflicted. Of course, in Colonial Pipeline, the ransomware attack did not hit their OT systems, but the concern in the organization was that these attacks could have spread into the physical infrastructure and caused lasting damage. This is why they shut them down until they could get rid of the attack. This is the kind of work that we're doing, and we are continuing to do this kind of work. These are the events that took place last year. These links are live. Risk and countermeasures in production, industrial robot vulnerabilities. I'll speak about that more. The vulnerabilities associated with gateways, protocol translation devices. There are so many independent vendor-specific protocols that when you wire up a factory, and nobody does this with one brand of equipment, you always have multiple vendors. So you need protocol converters. Well, these devices have a significant amount of horsepower. Their full-time job is translation, and they don't do an awful lot in terms of securing themselves. So unfortunately, they become a rather tempting attack point to intercept and modify messages and so on. And the research that we published in August of last year talks about how that's going. I like the name Lost in Translation, a tip of the hat to our research teams in Japan. And then the report on the Honeypot, which I just summarized. So let's take a look at what's going on in the future. The research against automation software tells us that programming languages used for industrial robots are a real ripe and tempting target. Here's the problem. None of these manufacturers has millions of devices in the field. You know, 6 figures maybe, 5 figures certainly, but not 7. What that means is if you are a third-party software vendor and you want to build technology to do something, let's say static code analysis, to get rid of you know, logic errors. Typical examples, you know, reading past the end of the file, going past the end of a buffer, indexing beyond the end of a table. There are static code analysis tools that will tell you, you really want to watch out for this, but none of those tools are made available to the creators of the languages list here, AS and Carl and KRL and Alpha and so on. They don't have third-party products because there's no market. You sell these things that are not hugely expensive, and if your market cap is, you know, 50,000, that's a big number. How much are you going to make after going to the trouble of handling a specific language? Well, not enough. So there are no tools there. But that in itself isn't the big problem. The big problem is that these languages are extraordinarily powerful. You can access file systems, you can create directories, you can read data from a file, and that file can be internet connected. You can do call by name, and that name can be an external reference. And you can access external data, read and write from these devices. And with the absence of any kind of inherent security controls, any rules in the language saying, you know, we're not going to allow you to read this without an explicit permission of some kind, it means that these are extraordinarily powerful and relatively easy to hack environments. What's worse, let's say you're a company and you're using one of these technologies and you come up with a really cool way of, you know, aligning the component and then performing the finishing on the piece. Well, that's going to be, you know, 500, 1,000, 1,500 lines of the code in this particular language. It's not Perl. It's this customized language for this particular robotic device. Well, you're going to share that. And there are users groups for all of these technologies. And the users groups share their goods. Back in the early days, when I was a programmer, before I joined IBM, we had a group called SHARE, it's still around, Society to Help Eliminate Redundant Effort, SHARE. It was for IBM users, and they passed around code that would make life easier for other programmers. You got a quick way to, say, format a packed decimal number so it prints out as a check with a $sign. Yeah, we can all write that code using a high-level language. It may only be 1 or 2 statements, but why not just put out a routine, call it a macro, subroutine. Code sharing has been around almost as long as code has been around, and it's going on here. And so you have repositories. They may be in GitHub, but often these things are independently set up through the users groups of these technologies. And there's not a whole heck of a lot of governance on those. A bad actor could insert a backdoor into some of these routines. They could modify them to allow side effects. This is the particular area that I'm concerned about, the file and directory access. With that kind of stuff, you can go to a lot of places. You can change the state of the machine. You can cause it to do things. You can make big changes to causing the device to go way out kilter. You can make small changes to cause the device to, jump forward, to cause the device to just simply misrepresent what it's doing. You can change the parameters of execution, looking at the third of the 4 columns. Read and execute from code from a long way away. There's no permissions involved blocking this, and the external communication area I've already discussed. Now, stepping back to a slightly higher level, here are the difficulties when attempting to apply information security principles to the factory environment. The first thing is IT systems tend not to have very long lives. In fact, most IT at this point can't even be depreciated because according to FASB rules, if the equipment loses all its value within 5 years, you can't depreciate it. It's not a capital investment. It is just an expense. It has no value, so you just throw it out, which means we have 3 to 5 year equipment life cycles. We go through refreshes fairly frequently. Few people in IT are using professionally the laptops that were standard issue 5 or 10 years ago. But if you go inside a factory, 10 years is not a long time. Could be 15. You go into remote IoT environments, it could be 20 years or 25 years. When you look at some particular class of equipment, this is not specifically factory, but in healthcare, the gear that's used in a hospital has to be certified in the US by the Food and Drug Administration. And the software load for that is part of that certification. The certification process takes 5 to 7 years. And if you change the software, you lose that certificate of use. So when you go to the hospital, a technology that is taking care of you is running 6-year-old software. Don't be surprised to find out that your heart monitor is running Windows XP, or that your automated hospital bed is running Windows 7, as is a lot of factory equipment. In fact, when TSMC went offline a few years ago, what had happened was a technician had gone onto the factory floor with his laptop to gather diagnostic data. He plugged his laptop into the robot and unwittingly uploaded a virus that had been contained and so on the laptop, because it didn't even apply to Windows 10, but it did apply to Windows 7. And the robot was running unaltered initial Windows 7. And not only that, but there were no fire breaks. And that bad code spread across the factory floor. It took about 40 seconds to infect 100,000 devices. The remediation took over a week, and it impacted Taiwan's GDP. Now, you might ask yourself, especially if you come from an IT background, why the heck would you run, vanilla Windows 7? And the answer is that's how the machine was built. And if you alter the software, then you void your warranty. So you don't really have a choice, which means we need to do other measures rather than protect on stuff on site, which, by the way, hearkening back to that first poll, yes, the most significant risk is bringing a device into a factory environment, crossing the boundary that protects that ICS configuration from those kinds of threats. Similarly, IT systems have narrow operating parameters, humidity, temperature, and so on. Factories, far away, not that. In the IT environment, data is the one and only thing that is of concern. Now, the basic rule of IT security is data shall not be lost or altered or inadvertently disclosed. The way we encapsulate that is there's an acronym CIA. It stands for confidentiality, integrity, and availability. Availability comes last. And in this case, when they're talking about availability in an IT environment, they mean the availability of the data, presuming a running process. If the whole system's down, yeah, the availability is a problem, but the issue is, what can we do to get the system back up? Whereas in a factory environment, the availability of the underlying service, not the data specifically, but the underlying service must be preserved. As an example of the difference between those, I like to consider an escalator in a store, in a shop. If you are on an escalator and it breaks, it doesn't just tumble everybody every which way. It doesn't just lose control and then roll down. No, a well-designed escalator, when it breaks, slows and comes to a stop. And even though it's not working, it's still useful as a stairway. That's industrial safety. That's ICS security. Preserve the availability of the underlying service even if the technology is offline. Again, in the IT theory, that's, do we need to, can we restart it? No, it's my pacemaker. You're not going to restart it. Thank you very much. You're not going to suspend operations while it runs some sort of an internal diagnostic. That's not the way ICS environments work. Now, having said that, some of the newer chip designers are coming out with technology that is bimodal. They have a special secure partition in which runs a processor and memory and network connectivity devoted to security issues. So the right hand of the device is doing what it's doing, monitoring the pressure in the line. The left hand of the device is generating logs as necessary, creating digital signatures, analyzing incoming messages, encrypting or decrypting traffic as needed. Those bimodal devices, however, are of no value to the ICS environment until they're incorporated into products which externalize those interfaces, so you can write code that would in fact handle encrypted messages, deal with a public key infrastructure, maintain the integrity of logs outside. Today, most of that work, to the extent that is done through safety systems, which means out of band. So in the IT environment, we talk about security by design as a goal. In the ICS environment, it's about productivity. And this important philosophical difference must be understood by both sides to have a meaningful conversation about securing IT. And the trend is not good. Factories are getting smarter, and as they do, the attack surface will grow. And I'm not just talking about the home office as an attack surface through which IoT can get in. I mean the factory itself. The bad actors are looking for money. They don't know a lot about OT yet, but the internet, it turns out, is a pretty good way to go learn. And as in this environment, as in so many others, there are a few hundred really talented, malicious individuals who come up with these attacks, but there is an entire supply chain. You can rent ransomware. You kick back, what, 20, 30% to the vendor who gave you the ransomware. You give them the target and some credentials, and they'll launch the attack, and they'll send you your 70 or 80%. And they're looking for an easy way to access, maybe it's intellectual property or cash or what have you. And so they're going to go after the enterprise. They're going to try to attack resources through cloud. They're going to go after individuals who are outside of the enterprise boundary. And they are beginning to sniff around digital automation controls, software-based environments that are connected to the internet. Sometimes the vendor wants to be able to get in and apply a patch. And so the tooling itself that you have protected in its secure environment is in fact running around on the internet without much clothing on. And you want to do something about that as well. And we'll take a look at that when we discuss remediation. How do we fix it? Well, it's not just real-time detection. We're going to talk about correct design and architecture. You want to categorically exclude certain classes of problems from arising. So how do we do that? Well, this is going back again to the service. The question is, what cybersecurity technical measures have you either put in place or plan to put in place to implement security on your smart factories? And we're looking at those that are already implemented. On the internal networks, and this is the blended environment, we're looking at maybe 2 out of 5 are visualizing assets. You can't protect what you don't know. Detection tools, almost half. Network segmentation, fewer than 2 out of 5 are segmenting the network. If the TSMC factory had been divided into 100 zones, they would have lost 1,000 machines rather than 100,000 machines. The perimeter And we'll talk about the value of the notion of a perimeter in a moment. Are we putting in firewalls? Are we planning to? About half of the time, yeah. What about intrusion prevention systems? What about securing USB devices? Again, half. Um, and what about applying antivirus? Now, I understand that the antivirus technology rarely finds a home in ICS. And the reason is very simple. ICS devices are constructed and implemented to perform a specific function with safety in place. They don't have spare headroom. They don't have spare processing power or network access or memory to run scans concurrently with operations unobtrusively. Now, those bimodal chip technologies that I mentioned a moment ago, those would be able to, in fact, run an AV scan over what's going on. They would be able to observe what incoming traffic looks like, acting like something of an IPS. They would be able to block traffic given sufficient rules, like a firewall. You're probably not going to create a rule set for a device, but creating a network segment and having a rule set over what kinds of traffic is allowed within it and what kinds of traffic is allowed to escape from it, that makes an awful lot of sense. So we're on the way there, but we're rarely more than halfway in most of these cases. And now what I'd like to do is introduce a concept that is not very well understood in the uh, ICS environment, but it's coming on rather fast in the IT environment. And that's the notion of zero trust. Now, the name is confusing. In fact, when I first heard it, I was put off as well. Obviously, it's not zero trust. What it means is verify, then trust. You do not presume something is trusted by merely saying, oh, it's here. The fact that a process or an individual is on a segment of the network does not necessarily mean that they should be there. It does not mean by any means that they should have access to everything that that segment connects with. So the principles of zero trust are we do not want to have the notion of a perimeter. The notion of a perimeter is misleading. And in fact, the illustration to the right is a painting of Joshua at the Battle of Jericho. The initial impetus behind Zero Trust was a group called the Jericho Forum, which started in the late 90s, and it was made up of CISOs who wanted to get rid of the notion of the perimeter as a security boundary. It doesn't work. Uh, Hackers attacking the Pentagon's system commented that it was kind of like a Tootsie Roll Pop. It was hard and crunchy on the outside, but soft and chewy on the inside. We want to get rid of that. We want to protect what needs to be protected where it is. So Zero Trust says don't assume there's a perimeter, whether it's the cloud or your own devices. We are going to have a source of trust, and you have to appear to that source of trust. And there has to be a context of identity management. I have to have a system to which I can refer saying, is this really Bill? Should he really be here? Is the system he's asking for really something he should get? Is the service he's trying to run, is the process he's attempting to invoke, are those things that he has been permitted to allow? Do we need to take an interrupt and go see if he's allowed to use those things? Well, that's a decision that your identity management system should be able to support. But you assume minimal need to know. You assume that we're going to authenticate everybody, and for critical tasks, we're going to use multi-factor authentication. Now, there was a bit of a kerfuffle when one of the vendors that provides a multi-factor authentication capability said, this is much better than an SMS message or a phone call. Yeah, that's probably true, but an SMS message or a phone call is a heck of a lot better than an 8-character password with some of the letters replaced by numbers, okay? So the goal behind Zero Trust is you force individuals and processes to authenticate themselves, you verify them, then you trust them, you track what they're doing, and you enforce separation of duties among those environments. That's what Zero Trust is. And it is entirely applicable to ICS environments. It is entirely applicable to any kind of silicone-based life that we have. for use. So again, why is smart factory security hard? Well, some of the systems can't be patched. They're not patchable. The devices don't have AV on board and they never will, not till we get to a new generation of technologies. Unfortunately, there's still a dependence on the notion of a perimeter. Segmentation can resolve some of that, but there has to be a balance. You don't want to segment the network so much that now instead of worrying about a flat network with easy traversal, you're worried about managing 10,000 security profiles for every zone. The harshness of the environment excludes certain traditional IT technologies from even playing in that world. The fact that there are conflicting architectural mandates, the notion of safety and security that's core to ICS is unfamiliar to people that are looking at the confidentiality, integrity, and availability dogma. So those have to be surmounted. You can take a look at the traffic on the network without slowing the network down. You can look for indications of compromise without slowing down the actual process of your critical systems. You can secure access to your safety systems without rendering them or disabling them from performing their tasks. And the global deployment, meaning you have to go somewhere to put this stuff, and sometimes somewhere you want to go to may be a hydroelectric power plant deep in the jungles of the island of Java, and you don't have a data center nearby. So there are real significant things. My favorite example of the dispersal of IoT, the most remote and hard to repair IoT device is the Voyager spacecraft, which is now over 20 billion kilometers away. It takes a message 19 hours, 20 hours to get there. So if you wanted to set up an SSH link, that would be a 6-day process just to establish the handshake. So not only that, but they're down to half power, down to 240 watts. They only have about a quarter of a MIPS of processing capacity, and that's among 3 processors. And I think they've got about a third of a meg of storage on board. So it's a real remote device. It hasn't been modified in over 40 years, and it's still ticking. Way to go. And here's hoping the Hubble comes back. So what do we do if we want to collaborate? Well, the figures here show the answers to the following questions. What departments should be involved? Both IT and OT. Yes. But where do you actually see it? Out of 500 people, only 12%. That's 1 in 8 actually have IT and OT collaborating to develop their security environment. Now, most organizations have a habit of being siloed. We've got to figure out a way to break down. In this case, this is one of those perimeters that we really need to figure out how to bust. You got to find some man or woman in your organization who knows IT security, but is also capable of going jaw to jaw with somebody from the OT side. They do exist. They're extremely valuable. Again, this survey was run in the last quarter of last year. And what we find is that where you do collaborate, you get stronger results. And here's a proof point for that. What measures have you or plan you to implement? When IT and OT work together, 2/3 say they're going to do a firewall. That's a win. That's good news. Nearly the same amount say we're going to do an intrusion prevention system. We're going to do a better job of protecting USBs. The only place where a non-collaborative environment doesn't measure up is in the notion of backup. And that's interesting because the IT people will tell you got to take backups and you got to take them off and you got to check them out. Well, yeah, that's all true. But most IT people who take backups regularly do it because they suffered a bad thing go wrong, usually in their personal environment, often because they forgot to check that the backup had properly been stored and was recoverable before they sent the machine back to, well, let's not get morose, but I'm having flashback. The point is that you need to do these things, and when you work together, network segmentation, my gosh, barely more than 1 in 3 do that when they're not collaborating. More than half work on segmenting the network and you work together. We make each other stronger working together. Collaboration can improve cyber resilience, which is improving defense and shortening recovery time. So here's what you need to do. I want you to find an IT person you can talk with and figure out how to segment the network. I want you to monitor your safety systems and consider out of band where possible and look at your network traffic non-disruptively, looking for indications of compromise, messages that have no business being on your network. I want you to take a look at your supply chain, not just the gear, not just the hardware, but the software. For that code that you develop in-house, what are you getting off of shared resources? For those critical software patches that you install as part of running your normal operation, ask your vendor how they verify that that stuff's clean. And for those robots that are using shared code segments from user groups, how do you know that stuff's good? Somebody's going to have to take a look at that. And yeah, well, we're not the biggest person in the environment. We're not going to be the likely target. Everybody is a likely target. It's not like the bad guys go through a list, a back issue of Forbes to say, what's the biggest factory we can hit? They go through back issues of Forbes and say, let's get a list of all the factories and hit as many of them as we can. Now, where it's possible, upgrade OT to newer technologies. Push your vendors to, give you a hand here. Now, some of this is probably going to take regulatory action. Hopefully, it won't end up with lawsuits where we shed the dysfunctional approach that says, as of today, anybody who's using a personal computer or a smartphone is a hobbyist, right? It's caveat emptor. There is no warranty. The EULA basically says, if anything goes wrong, it's your fault. And if you tell us it wasn't, then we're going to go to arbitration and we get to pick the arbitrator. Now that's going to come crashing down. We've had enough near misses recently and some significant hits that I think we're going to see legislative action saying you've got to provide products. And yeah, I remember in my early days at Gartner, people say, well, the massive buying power of the federal government. Well, yeah, but if you're a vendor and your federal contracts depend on you having a particular feature, are you going to retool your entire production line to build that feature? Don't know. You're going to add that as a special US government certified feature, and it costs this much more. So yeah, the buying power of big consumers is not going to be that important a factor. But pending legislation, ask your vendors that you want to be able to do something. I'd like my OT to be a 21st century participant in securing my cyber environment. When you're doing architecture work, bring in the IT security generalists. Now, I didn't speak about this explicitly. 5G is really, really complex, and it is far from here. The bulk of the real stuff in 5G is in the 3GPP's REL 18. REL 18 is not going to be done until the end of 2022 or the first half of 2023, which means we're not going to see true 5G capable devices in the market until the end of 2023, because that's the manufacturing cycle. Yeah, you'll see some folks saying my stuff's 5G based on a current specification as it is commonly understood, but that's going to get us into the same problem we had a number of years ago when there was a delay in the construction of Wi-Fi, and for a while we had 3 incompatible Wi-Fi standards. 211 A, B, and C, I think, were implemented differently and they didn't interoperate. We don't want to do that with 5G. Too much money's on the table. But one good thing about 5G is the non-public networks give you a greater degree of control over who can even participate. A 5G non-public network to govern, say, a factory or a distribution center or a warehouse or even a dock, a port, will be much more secure than relying on a Wi-Fi infrastructure and stringing wires across the environments to support cabled infrastructure is a non-starter. And finally, I'd ask you to use secure coding practices. There are there's a lot of work done on making code more easily validatable, designing code, call it clean room software, a concept that was knocking around back in the 80s, to try to make code more explanatory and able to be validated. That brings me to the conclusion of my planned remarks. I promised a set of references. These are some articles that talk about it. The Society 5.0 is uplifting and worth your time. So, and here's the credit. Brendan Dawes developed this material.